Namaste. All right, good morning, guys. All right, here's what we're going to do today. I'm going to show you guys how to do what is called vector addition. You read about it. It's in section 11.1. Okay, I talked a little bit about vectors before. And let me show you how to do some problems in what's called vector addition. So if you take a look at this one, we always start off with this one right here. It's called a drift problem. Okay. And again, make sure you're taking notes on this and make sure you're watching the entire video. All right, so what we have here is, let's say we have a boat and it's in a river, okay? And the boat its motors can push it like 3 miles per hour, and the river is a fast current, and the river's current is going 7 miles per hour in that direction. So obviously we know that if the boat points straight up there, it's not going to wind up that way. It's going to drift somewhere in this direction. And the question is, what direction is it going to be going in, and exactly how fast will it be going? Is it going to be going 3 miles an hour plus another 7 to make 10 miles an hour? Is that what its real speed is going to be, or not? So here's how we do it. Now, I'm going to erase this, and since you guys can pause the video whenever you want, all right, I'll let you guys get it. You know, you can do that in order to draw this in your notebook. All right, but watch how I do this, okay? Now, the first thing you're going to want to do is you're going to want to get your ruler. Now, normally, if we were in the classroom, I'd be using my meter stick, and I'd have the bigger chalkboard, so I kind of got to do this, you know, a little bit handicapped way. And the first thing you're going to do is you want to pick a scale. Okay, so you're going to draw the vectors out, but watch how I do that. You pick a scale. What does that mean? On your paper, with your ruler, you say that 1 centimeter on your ruler is the same as 1 mile per hour. Okay, then what I'm going to do is I'm going to draw a little dot, and the dot is going to represent the boat. And essentially the boat has 2 vectors working on it. It's got a 3 miles per hour speed in that direction, and it's also got a 7 mile per hour speed pushing it in that direction right there. Okay, so I'm going to show you how to add these 2 vectors, and just so you get some language down here. Okay, vectors have parts to them. The arrow part is called the tip. Write that down, tip. The back part, the opposite part, is called the tail. Tip, tail, tip, tail. Okay, and the way we add vectors is we say we add them tip to tail. Now what you're going to do is you're going to redraw these vectors, and you're going to draw them to this scale on your paper. So leave yourself some room on your paper to do that. And you're going to draw them the way we say it, tip to tail. Now when I do this, all right, I'm going to teach you guys to draw them to start with 1 and then add the other one clockwise, go clockwise. So I'm going to draw this one first, and then clockwise is this way. Then I'm going to add the 7 to it, all right? And that's going to make more sense, especially if there were more speeds involved there, like, you know, maybe there was wind pushing it like that. Then I would add this one, then draw this one, and then draw this one, okay? Clockwise, all right? Okay, so anyway, let me do this. So 3 miles an hour and 7 miles an hour. So what I'm going to do is on my chalkboard, I'm going to draw the 3 mile an hour first. Okay, so I'm going to take my chalk, I'm going to draw it to scale, and it's going to look like that. Okay, all right. Now, you guys are going to be a little more accurate than me because you guys are using a pencil or a pen. All right, pencil is probably better because you probably make mistakes and erase. All right, and I'm using a piece of chalk, which is kind of thicker, so it's not going to be as accurate. Okay, but here is my 3 miles per hour drawn to scale. Okay, now I'm using inches because I have a chalkboard that's a little bit bigger. You guys use centimeters because you have a piece of paper and it's smaller. So, and then I'm going to draw my 7 to it, tip to tail. What does that mean? It means I'm going to draw the 7 mile an hour vector starting where this one leaves off. Okay, and so I'm going to do that in the same direction that the 7 is going. The 7 is pointing that way to the right, so you draw it to the right, starting here. That's the only difference. So here I go. All right, and that's pretty accurate. And there's my 7 miles per hour. Okay, all right, fine. So what's my resultant? Remember, that's the answer that you get when you add two vectors. It's called the resultant. Well, my resultant it always goes from where you start to where you end up, like, you know, like displacement. Start, end, start, end. Okay, so I'm going to draw a line from where I started to where I end up. Okay. Now you see that direction right there? If this was really 3 miles an hour that way, and then the current's pushing is 7 miles an hour that way, because I drew it to scale, the boat would go exactly in that direction. Okay. And that's why we developed this method to solve problems like this. Now this is useful in everyday life, not so much while you're driving a car, but think about when you're in a vehicle like an aircraft. Okay, if you're flying in an aircraft and it's flying 400 miles an hour, but it's in a 30-mile-an-hour crosswind, the aircraft is getting pushed off course, and the pilot and the tower have to compensate for that, because if they don't, on the 2,000-mile flight from here to Orlando, Florida to Disney World, by the time you get down there, that plane's going to be in the Gulf of Mexico, okay? Because it would have drifted off course that far. Okay, so anyway, we want to find out what's the real speed of the aircraft. Well, you measure it. Put your ruler up there and measure how many centimeters it is. Now I'm getting about 7.5, a little bit over 7.5. I'm going to say 7.6. Now, if you don't get exactly 7.6, I want to say this right now, that's okay. This is not an exact method. This is an approximate method. So if I get 7.6, you get 7.5, you're still good. Let me repeat that. If I get 7.6 and you get 7.5, you're still good. Now, if I get 7.6 and you get 2, you're not good. Something went wrong, and go back and check what you did. All right. So 7.6 miles per hour in that direction, that would be the true velocity of the boat. It would be going in that direction at a real, actual speed of 7.6 miles per hour. Tracking with me on that? All right. And if you're not, see me during the office hours. Okay, let me do another one for you. And I'm going to do one that has like 3 vectors. So, and these vectors are going to be force vectors. Forces are measured in pounds. So let's say I have an object, and the object is right there, and somebody is pulling with 5 pounds of force to the right, so they're pulling the object this way, and another, let's say it's like a toy that some kids are fighting over, and all 3 kids got the toy, and one kid's pulling this way, and one kid's pulling this way with 4 pounds, and then another kid is pulling this way with 7 pounds. Which way is the toy going to go? So if you imagine 3 kids, one pulling this way, one pulling this way, and one pulling this way, all at the same time, what's going to happen to it? What direction is it going to go in? So, all right. So again, I'm going to do this tip to tail, 4, 5, and 7. Now, make your scale 1 centimeter is 1 pound. Okay? And watch how I do this. I'm going to start with the 4, then I'm going to go to the 5, then I'm going to go to the 7. Okay, so I'm going to draw it to scale. I'm going to draw a little dot. That's my start point. So I'm going to draw the 4 according to my scale. You might want to be doing this while you're taking notes on the video. So maybe pause the video while I'm speaking to draw it out in your notebook so we can do it together. So here's my 4. And then I'm going to draw the 5. Where am I going to draw the 5? Tip to tail. That means I'm going to start drawing my 5 right here. I'm going to draw it that way in the direction that it's actually going. It's going to the right. So I'm going to draw my 5 right there. And notice how it's a little bit longer. 5 pounds. Now I'm going to draw my 7. Where am I going to draw that? I'm going to draw it where the 5 leaves off. You always draw the next vector where the last one left off. Okay? And I'm going to draw it in the direction that it's actually going. The 7 is pointing down. All right? So I'm going to draw it pointing down. And I'm going to make it to scale. So okay? That's about right. Okay. Now, notice I ended up right there. Now I'm going to draw my resultant, okay? And that always goes from where you start to where you end up, like a displacement. Start, stop, start, stop. And you put the arrow of your resultant where it ends up. So I'm going to draw it right now. Okay. Starts here, ends there. So if you had 3 kids pulling on this, the toy would wind up going in this direction. Okay. So the 7, notice it's kind of going in, downward because the one kid is pulling with 7 pounds this way. It's kind of going this way at the same time because the one kid's pulling with 5. All right. It's not going completely downward because the other kid's pulling up against the 7-pound kid with 4. Now, what is the resultant amount of pounds on the toy? Okay. Well, I'm going to go and I'm going to measure it. And you measure this right now. Okay. Pause the video. And I got 1, 2, 3, 4, 5, just about 6. I'd say just under 6. I'm going to go with 5.9. Okay? Now again, if you didn't get exactly 5.9, if you got 6, you're okay. If you got 5.7, you're okay. If you got 1, you're not okay. All right? So 5.9 pounds in that direction. That is my resultant. Tracking with me on that? All right, okay. So, now what I'm doing is I'm going to put on the video, I'm actually putting problem number 4, which is this, okay? So, all right, if you're looking on what I gave you, I got problems 1, 2, and 3, and these are vector problems like that, like I just did, and I'm going to want you to draw them out on a piece of paper. Take a picture, insert it in a Google Doc, and then send it to me so I can check your answers. Make sure you also box off your answer like I did. Like I got 5.9 and then boxed it off, all right? So make sure you do that. That just makes it easier for me to grade. And what I did, if you look at the bottom of this, there's no number 4. And somebody is going to say to me, they're going to send me a message, and they're going to say, Mr. Golis, there's no number 4. Wrong, because I'm putting it right here. Yeah, aren't you going to feel foolish? Matt Fontaine? Emily Cronin? Because we don't watch the video all the way through, and you are going to feel foolish, or in Espanol, estúpido. Comprende? All right. So here we go. Number 4 is actually this right here. So number 4 is quattro, 4 vectors, and you have 4 pounds in this direction. You have 6 pounds in that direction. You have 2 pounds straight down. And then you have another 2 pounds pulling to the left. Okay? Now, how are you going to add these? Well, the same exact way. Start with a 4, and I'm just going to sketch it out for you. I'm not going to do it. I'm going to sketch it out for you. So you pick your scale, say 1 centimeter is 1 pound. Draw your 4, and then do the 6. Go clockwise. That's this way. 6 is going to be something like that. You draw the 2, because that's the next after the 6. And then draw the other 2 like that. Tracking with me? Okay. So again, those of you guys who watch the whole video, you're going to do this just, oh yeah, and your answer will go from there to there. Those of you guys who watched the whole video, you're going to do absolutely swimmingly on this. Those who didn't, you're going to be confused and you're going to skip number 4, and you're probably going to wind up pushing a shopping cart, all right, on Tioga Avenue once the quarantine is over for the rest of your life. Okay? All right. So anyway, that being the case, try the problems I gave you. Come and see me during my office hours. All right? And good luck with this. And remember, enjoy your apocalypse.